Hello everyone, and welcome to Advanced Engineering Talks, a podcast created by the Advanced Engineering team. AE Talks brings together some of the newest and most innovative minds in engineering and manufacturing to help better the future for our industry. We hope you enjoy the series.
We won an award from Innovate UK, which is obviously that provided a little bit of money to get the project started, and also very importantly, it provides sort of the coaching and mentoring you need to turn the idea into a business. So when I started, I was just a humble engineer, didn't understand anything about equity or term sheets or go-to-market strategy. So they help by basically teaching you a lot about that.
Okay, well, hello and welcome, everybody. I'm once again delighted to welcome you all to another Advanced Engineering Talks podcast, where innovation never sleeps. This month, I'm delighted to be joined by Alasdair Aegerter, CEO and founder of YEET Aerospace, which, as I think you put it yourself, Alasdair, on your website, your aim is to create a planocopter for high endurance and high payload eVTOL capabilities. Alasdair, I've probably not pronounced your second name that brilliantly, but anyway, welcome. How are you doing?
Thanks for having me. I'm doing well.
Great. I mean, what's particularly interesting and why I thought it would be great to have you on one of our podcast episodes, of course, is that you're relatively young. You're 28, pretty young, if you don't mind me saying so, especially in terms of the advanced engineering sector. But all the better. It's absolutely great to see people like you and your young team coming through with new innovation and ideas in the aerospace and urban mobility sector. Young though you are, you've been extremely busy since graduating from Bristol University, and not least having been selected, amongst other things, as one of Innovate UK's Young Innovators for 2022-23, which means a very nice share, no doubt, in their 1.2 million innovation fund, 1.2 million pounds, which is shared between you and the other Young Innovators. It's also meant lots of nice coverage in general media, such as the Times and the BBC, to name it a few. So really exciting stuff. Tell me, Alasdair, to kick off, what got you into all this and what's your background?
So I'm an aerospace engineer. That's my background. I've always been an aeroplane nut. I've always had my head turned skywards, even from a very young age. I studied aerospace engineering at the University of Bristol. I graduated in 2016, and then, as you said, had quite a prolific career working at lots of different places, building machine parts, composite propellers. Spent 3 years at Rolls-Royce making blades for the Ultrafan engine.
Oh wow! That's interesting, by the way, because I don't know if you noticed that. Obviously, we've got you scheduled as a speaker at Advanced Engineering Live on 1st, 2nd of November. And you may have noticed that we've got Pete Young, Chief Engineer of Ultrafan from Rolls-Royce currently, who is going to be speaking about the Ultrafan. So that sounds like a really interesting background that you've had there, their sustainable engine. But anyway, I'm butting in, but carry on.
Yeah, it'd be interesting to share the stage with some of those people. It's sort of, interesting. But in my last job, well, I've always been fascinated with sort of pushing the boundaries of aerospace technology, and I'd been watching closely for a while the development of drones and these new eVTOL aircraft. And there was a space of a few years where I was just playing with different designs in my own time, thinking about if somebody wanted to design something just really off the wall with just the best performance you could imagine, how would you do it, and how would you manufacture it? What kind of architecture would you use? What would it look like overall? And then in my last job, I was working for a company called Airborne, which is a company which does composite manufacturing for lots of different companies. And whilst I was there, we were helping build parts for the VX4, which is Vertical Aerospace's prototype aircraft. And I don't know, I looked back at the things I'd done and the things I wanted to do, and decided that, you know, the one thing I really wanted to do with my entire life was try and build this aircraft, which I'd been designing for several years. And I at the time I didn't really have the knowledge of how to do it. I mean, I had the technical knowledge of, you know, how to build parts for an aircraft. But what I really needed to do, or the only way I think I could envision that the aircraft would ever get built in its entirety, was if I went away and founded a company to build it myself, because there wasn't anybody else I could go to with the idea and say, I think we should build this. The only way it would get done is if, you know, I took it upon myself to do this difficult challenge. So I left and I started my own company, and I've transitioned, or I am transitioning from being an engineer to being a CEO, and I'm sort of leaving the CAD laptop to one side, and the PowerPoint presentations and the spreadsheets and the pitch decks are what I spend more of my time doing now. But at the same time, I'm pulling a team of really good experts together who are helping develop this technology. The original plan, to be honest, was to build a small aircraft. But then when I looked at the market and I looked at what would be technically feasible to do, or what would be how we were going to do the product development in the first place, because we were always going to build small prototypes before we built the full scale aircraft. And then I looked at that and I said, well, if we're going to build a drone, what is essentially a drone, then we should look at actually trying to use that drone for something anyway. And then there's been a soft pivot towards just doing drones for the sake of drones anyway. And actually, that's a really good decision, because when you look at the growth of the drone market and the growth of the unmanned aerial vehicle market, I think there's much stronger opportunities there than there is probably than if we were to make an eVTOL. And when we look at some of the challenges or some of the problems that we're helping redress by making a unmanned aerial vehicle, then we're helping solve some of humanity's problems, which if we were just going to be building a light aircraft for recreational purposes, we wouldn't be doing quite the same job. So
do you see then that as an unmanned vehicle, it would be primarily, for instance, transporting goods or cargo or emergency equipment, for instance, or could it? But you could see potentially down the line, in the longer term, maybe people as well, if they trusted it as an unmanned vehicle. Perhaps there's also a sort of perception to get over that over perhaps some years might take.
Yeah, we're happy to let other people lead the charge in terms of moving people and moving cargo. I think that's a really tall mountain to climb, and I think other people are going to be much quicker at doing that, and other people are sort of going to blaze that trail in terms of building the public trust in terms of moving people. When the really special thing about the planocopter is that it has its performance in terms of its range, its speed, and its endurance is much more akin to what you would see on a fixed-wing aircraft. And that range, speed, and endurance is really useful to customers in particular fields. And when we looked at who it would be most useful for, or the types of missions where it would suit best, the arrows pointed towards things like maritime surveillance. That's what our focus is mainly on at the moment. So things like illegal fishing. Illegal fishing, most people don't know this, but illegal fishing is a huge problem around the world. Over 50 billion pounds worth of fish are stolen every year. Most of that is stolen from about 50% of that is stolen off the African coastlines, where the countries typically don't have the economic means to do anything about it. And that's because maritime surveillance is traditionally done using planes and boats and helicopters, all of which are very expensive to operate.
Right.
So if coming along with this really easy to use VTOL drone that can also fly a really long way and can fly very fast, you suddenly got this really cheap tool that's easy to use that can be used for maritime surveillance, and you can use to effectively tackle those problems. And then there's also things like human trafficking, legal immigration, drug trafficking, and then some of the softer tasks like oceanography. And we are also looking at things like if you are a diver, if you're a recreational diver and you want to go diving with whales, at the moment it's not so easy. Well, you have to know where the whales are to go and dive with them. Which is a bit of a lottery, but you can use a drone to go and spot them. And the drone that we're using to spot illegal fishing vessels or drug trafficking vessels, it's not very difficult to then also retrofit that to be able to look for whales. So we're creating this product which can do a variety of roles in the maritime environment, and then we're seeing where we can go from there. Because one of the challenges was really is deciding what to do with the drone, because drones are so versatile, and they're used in such a wide range of industries. A drone is used for filming, but it's also used for agriculture, but it's also used for all these other things. But if you want to make a successful business out of a piece of technology, you have to be focused on a specific customer, and the product has to be it has to be designed for a specific mission. It can't be too generic. It can't be a complete jack of all trades, master of none. It has to have some specialization to it. So,
and at least maybe and it probably from a business point of view as well, I imagine just concentrating on that, perhaps the most obvious one that it can do as an end use is perhaps the best idea. And then maybe going forward, once it's been seen and used commercially or demonstrated, perhaps overlapping uses might be ultimately seen by other sectors, who might invest in it for that use. I don't know, but
well, you're right. I mean, when Innovate UK graciously helped me by putting me in the Times and putting me on Radio 4, a bunch of people came back in contact with me. One of them was from an agricultural company who was saying exactly that. He was saying at the moment we use drones for monitoring crops, but the drones have a limited speed and range and payload, so we can do a field at a time, but it's too slow, and because it's too slow, it's not economically viable. So a drone that can fly a greater distance and can cover much more ground much more quickly can be used in that role and be a much more economical tool, and can help farmers on a much larger scale.
Right.
So in this country, well, in any country really, you can use a drone for looking at the health of crops, and in this country the farms tend to be small is a relative term, but in this country the farms are small compared to Brazil, where the farms are the size of small countries.
Absolutely. So that makes sense. I mean, what is it that you would say, obviously further and faster for these sort of economies as well? What is it that will be that unique about the propulsion or the design of the vehicle that will enable you to do that in terms of the fuel or the technologies that you're using?
Sure. The two key elements of the design are the fact it uses wing-borne lift for most of its flying, and it uses a coaxial propulsion system as a single means of propulsion for hover and forward flight. So it resembles an aircraft from the 60s called the Pogo, the Convair Pogo. Plane bus will know what that is, but it also resembles in some ways the Ingenuity Mars helicopter, which uses a coaxial rotor system for hovering around.
Mm.
So it combines these two elements. It combines an extremely efficient hovering lift propulsion method. It uses its wings for forward flight, and it uses the same propulsion system for hovering and for flying forwards. So there's no redundant pieces of redundant propulsion mechanisms that you don't need. So at the moment, the market started with quadcopters and then has expanded onto other types of multi-rotors, which is aircraft which hover around. The problem with that is that the two problems with that is hovering around isn't as efficient as flying around, and using lots of small propellers is energetically inefficient compared to using one really big propeller, which is what a helicopter does. It comes down to a physical principle called disk loading, which is basically it's more efficient to move a really large volume of air and accelerate that by a small amount than it is to move a small amount of air and accelerate that by a large amount. But that's just the technical things. And then the other thing is that obviously it hovers, and then once it's in the air, it tips forward into forward flight and uses its wings. And at that point, it's flying around with the same efficiency as any fixed wing aircraft, which is good. So sometimes I describe it as it is as efficient, it is as good, if not better, than any fixed wing aircraft you can get. But it has VTOL capabilities, and there's very little compromise. There isn't any compromise in the performance that we have to introduce in order to do that. So yeah,
in terms of what fuel, for want of a better word, is it purely charged electric, or is it hybrid, or what's that background?
It's battery electric at the moment, and it's going to be battery electric for the foreseeable future.
Okay.
That's the standard thing for drones. It being fully electric means that it's obviously very cheap to use. And it's very logistically easy to refuel. Batteries. The problem with batteries is that obviously they don't have much energy in them. And that's precisely why you need to compensate by doing some clever things with the design to try and get better physical performance.
Also, I guess, is there a weight issue with batteries? I guess that's improving all the time, but
the weight. So it's the energy density is how we describe it. So for the given amount of weight, how much energy do they store? So they contain a lot less energy per kilogram than any fossil fuel, so kerosene or whatever you're putting into your aircraft engine. And that's why all of these drones and these eVTOLs struggle for range and performance, is that batteries are just don't have as much oomph to give.
So that's your trade-off, is the way in the design and the aerodynamics and the way that you're using the rotor system to move that air much more efficiently to make up for that, which is interesting.
Exactly.
Yeah. Oh, really interesting. Yeah. And what are you it's like, sound like a rude question in a way, but what are you using at the moment with the investment money that you've got? What are your priorities in terms of development? And also, as part of that, to what extent, I guess, you must be looking for new investment and more investors, and how's that all going? And what are your milestones that you're looking to use that sort of money for?
Sure, yeah. So it has been enough for us to do the prototyping on the drone. So obviously the rationale is we can prove everything at quite a small scale. And then it's fairly easy to scale everything up. We have a flight controller or a flight computer, and what we do with a small motor and a small airframe, every time we prove that it works effectively at a certain scale, we just get a bigger motor and a bigger battery, and then we've just been like sort of getting heavier and putting more things on at every stage. So our first prototype was under a kilogram. Now we're building one which is about 7 kilograms, and then by the end of the year, we've got all the components ready to do something which is about 15 kilograms, and that's kind of the weight we need to be at for the types of missions that we want to do and the range and endurance. But yeah,
it may be possible then, by the way, to that 15 kilogram one, depending how you get on, to demonstrate it or to showcase it at least at the Advanced Engineering Show in early November. So
yeah,
there might be something to aim for.
We'll be bringing along a sort of showcase. We'll be bringing along a version of the aircraft, TBD what version.
Yeah,
but we have something. We have something which we've been putting on stands at some of the sort of showcase events at University of Bristol and UE. It's a version of the aircraft which does a little dance, and usually people are quite interested in it. But
fantastic.
the bigger it is, the more impressive it is. So if we can get a bigger one than that, then absolutely. But you were asking about funding. We won an award from Innovate UK, which is obviously that provided a little bit of money to get the project started, and also very importantly, it provides sort of the coaching and mentoring you need to turn the idea into a business. So when I started, I was just a humble engineer, didn't understand anything about equity or term sheets or go-to-market strategy. So they help by basically teaching you a lot about that. And then throughout this year, we've secured some other grants. So we've applied for some other grants and won a bit more funding through that. And then there's just a sort of ladder of success which is to be climbed, where you get some small grants, you get some bigger grants, you get a bit of traction, and then we're also preparing to take on some private investment next year as well. So it's all coming along. The funding wise, it's all coming along.
That's great. Yeah. Hopefully that, some of the more that you get yourself out there, like this podcast and maybe shows like ours as well, and Advanced Engineering, might give you more of those sort of opportunities as well, hopefully.
Yeah, people have been very quick to help, I think. When I talk about this, people see a project like this, which is quite ambitious and has sort of wide-reaching implications and applications, and people think people just want to be involved in it, want to be involved in it, and when podcasts like this go out, usually people get back to me.
Yeah, that's good to know. Yeah. Which actually, before I forget to ask, I was quite intrigued. Why YEET? What does that mean? Where did you get the name from, and have I pronounced it right?
You pronounced it right. So YEET is not an acronym. YEET is a 21st century slang word, which means to move something quickly or forcefully.
Is it? I've never.
Yeah.
Is that an English word or not necessarily?
It's one of these terms. I'm not quite sure what the origin is. I think it came just from the internet somewhere. And entered.
So you yeet something across somewhere. Yeah.
That's correct. Yeah. So it's a bit of a controversial name in some ways. It's not the name that somebody might typically choose for a startup. I wanted something quite memorable, and also I looked at some of the other drone startups, and
like Joby.
Well, there's a company that one of them is called Whisk, and I thought,
Whisk.
If you can call yourself a whisk, that is actually like the word itself. If you're going to whisk something from A to B, that's very simple.
Yeah, that's actually very good, isn't it? Yeah.
I wanted to avoid a company name that had drone in the name, or sky, or anything that is like a little bit sort of like passe. So
absolutely, I think it works. I think, and I did quite like the nice stylized Y logo you've got there.
Oh, thank you. Do you know, I can tell who knows what the word means and who doesn't, because if I say it if I'm networking, for instance, and I'm speaking to maybe somebody of your generation, and I say it's called YEET Aerospace, there's never a reaction. But then I'll speak to another young founder and I'll say it's called YEET Aerospace. Like there's
Really?
always
So
a bit of a smirk.
It's a relatively young, it's a relatively new kind of word, I think, then, by the sounds of it.
It is, yeah.
Yeah.
It's a millennial term.
A millennium. Yeah. Yeah. That's interesting. And then in terms of what you do, how things have been going and what you've been finding out in your testing and your prototyping, what would you say have been your biggest challenges, and have you been surprised specifically by some things, and what sort of challenges might you be anticipating down the line?
Yeah, some things were a lot easier than we thought, actually. So the aircraft, the aircraft has like sort of, it's a new propulsion system and a clever way of actuating itself, and it does all of that using some very low cost drone electronics. And we were surprised with how quickly we were able to make it hover in a really stable way. And I was surprised at how easy it was to fly and then also transition into sort of a forward flight mode. So people, before I started the project, that's always people said to me, or they said, oh, you know, taking a hovering aircraft and transitioning it is really difficult. And before then, I'd never even flown a drone, and we did it first time, and it was actually really easy.
Wow.
So building it is quite easy, and programming it has been quite easy. But I think coming up with like a robust sort of testing program where we make a number of them and then test different things and then try and pull together the results of different tests to sort of integrate lots of different features at once is probably been the most difficult thing. So like the core concept is quite simple. Also, like the key elements of it are simple, but then when you start adding in lots of other gadgets, like, you know, the lidar, like a special GPS, and all of these kind of like things that you tack on, then it starts to get a bit more interesting.
And I suppose the more of that you add on, the more you have to build in again. I don't know, with the weight issue, maybe you have to make other things lighter to accommodate these things, perhaps, do you as well?
At the moment, it's got an abundance of lift. I can say that. It's a bit like a race car, actually. It's sort of like you get on the controls.
Wow. Yeah.
And it's got so much. Well, it's got enough thrust that we're not worried about weight at the moment. We sort of have a big reserve of weight which we can leave, which we can then later just add in more batteries. If we need to add more weight, there's always the option of just using a bigger battery, and then you've got, you know, more range and more endurance. But at the moment, we're fine for that. Yeah, it's more a case of if you're an engineer, you're sort of a perfectionist, aren't you? So we have a design, and it flies well, but then the challenge is, well, we need to make lots of them, and like we want our production process to be really simple, and we want the electronics to be simple, and we want it to be something that people will look
simplicity
at and want
is
to
usually
use.
The best success rate, isn't it? Keeping it simple.
So like, I mean, the thing that is amazing about a quadcopter, and I spend a lot of my time dissing quadcopters because they can't fly very far, but the reason they're so popular is that they're so easy to use, and like you can take someone who's never touched any aircraft or anything, and you can put it in their hands, and you can say up is up, left is left, right is right, and they can go away and fly it, and then you can, it's not a big step to then go away and use it for something. Conversely, if you were to give somebody a traditional remote controlled airplane, a fixed wing aircraft, something which has got that range and speed, it's the opposite. People are scared to use them. They're difficult to fly, and then once it's in the air, you've got to bring it down again. And we spend a lot of time practicing. Well, we spend a lot of time practicing flying on a fixed wing aircraft as well, in order to demonstrate some of the systems that will go onto the planocopter eventually. And it makes you realize that like fixed wing aircraft operation just has so many problems, and that's why the drones are so popular. And the biggest problem is obviously bringing it back down to earth is always the tricky bit.
I'm sure. I mean, do you think, with that in mind, do you think in its end use, let's say, I don't know, looking at crops, monitoring crops, and would the farming staff or whoever's looking at that be able to directly, they use it themselves? Would they probably need a bit of training, or would you think it's more likely that there could be a sort of agency that does it on the customer's behalf and operates it for them and gets back to them on the results?
That's a great question, because there are different ways of doing it.
Yeah.
And when we look at sort of like different business models, both of those are options. So the first one you described is you can just sell a farmer a drone, and then if the product is easy enough to use, then they could go away and use it themselves if they wanted to.
Yeah.
And some farmers are quite tech savvy, and they're really willing to do that.
Yeah.
But a lot of farmers are incredibly busy and don't want the time, and they just want to pay someone to come along and do it. In which case that presents then two further options. We'll either be selling the drones to other drone operators who are doing it for the farmers, and then the final option is we ourselves go out with our own drone and operate it for the farmers. So there's a litany of ways you can actually try and make money off having that aircraft. It depends on the use case. So for maritime surveillance, we're interested in operating it ourselves, at least initially, because that's what allows us to stay close to the technology. It allows us to stay close to the customers who are using it. So it gives us the opportunity to improve it as the customer is using it. And also it is a unique piece of technology, and we probably don't want to sell it immediately. We want to sort of keep it to ourselves for at least a little bit longer. But if it proves to be really successful, then like I said, there's different ways of making money off a drone, and we'll see how it goes. We'll probably try a few different things.
You could license bits of it out, I suppose, in some ways. And just going back to working with Innovate UK and so on, I always think that I think you're a great example actually as well of this. Is that UK has some great world-class universities that bring out R&D or innovation and that sort of expertise and knowledge. We don't necessarily in the UK have the greatest of records always in commercializing it and crossing that valley of death into commercialization and that kind of thing. Do you think that's I mean, how do you think that's perhaps improving? Do you feel that you've got opportunities in terms of doing that within the UK, or is it difficult to say at this stage?
It's difficult to say, because a lot of people compare the way entrepreneurism is done in the UK to the way it's done in other countries. And I'm not an expert, but the types of things that people commonly say is that in the United States there are a lot more spin outs, and there's a level of expectation that somebody who's doing academic work might find a way to try and commercialize it, whereas we don't have the same philosophy or the same ethos in universities here. And also, I don't know, people talk a lot about the attitudes to entrepreneurism in the UK, and I think in some ways the mindset of people in this country is a little bit anti-entrepreneurial, because that people are compared to like people I've met in the States or people from Europe. There's kind of like there's a fear of risk and a fear of failure, and I think that if you're an entrepreneur, you need to you really need to, you know, have a mental check on those two things. People,
Yeah.
It took me a long time. It took me a long time to get started with this project. I ummed and ahed on it for a long time, and obviously, like, there's a worry that the project might not work, or there's a worry for any founder doing a
Yeah.
startup that it might not work
course.
in some way. But it's you have to. You can't. You won't know until you try it, basically. And I
Yeah.
think the biggest difference between this country and or maybe other countries, or the reason why academics in this country don't want to spin out, is that that entrepreneurial drive just isn't quite there, I don't think.
Mm.
I'm not saying that in a pessimistic way. I'm saying that,
No,
right,
no.
we've got other qualities, but that sort of politeness and sort of like shyness is.
Yes, it's funny, isn't it? I think there is something there in that respect. I'm actually planning I think actually a week today I'll be doing another podcast recording with Richard Noble. He's the guy who used to hold the world land speed record, and he's going to be doing some. He's a serial entrepreneur and innovator, and I mean, I remember him when I was a kid. You know, he was like my hero was like saw him going along some salt flats at nearly 700 miles an hour, and he's at the moment he's back trying to do the again with thrust, with the water speed record, I believe. But I'm interviewing him next week, and he actually told me to go and buy his book, which is actually called Take Risk. So I've just had that delivered from Amazon, so I'm just going to give that a quick read because it should be quite interesting.
Sounds like a book I need to read as well.
Actually, yeah, you should have a look at it. Yeah, Take Risk. Yeah.
But yeah, you do have to take risks, and you know, Richard Noble was probably a great example of that. There has to be a special kind of drive in a person to do that.
I think
and
so.
I'm definitely going to be listening to that podcast with Richard Noble, because I want to see what he says.
Yeah. And I probably shouldn't say Richard is nuts, but I'm sure though that he thinks he certainly thinks in a different way. I think a different outlook on life, a different sort of type of person and the way they think, isn't it? Which is really interesting, and you need more people like that, I think. I mean, just going to just general day-to-day stuff. Do you guys? I think you said when we were chatting earlier that you do some work from home, but you're also based together with the team in Bristol. What's that like? What's a day like at YEET Aerospace when you're all together?
Yeah, so the project is based at the Bristol Robotics Laboratory, which is an incubator, which is a joint venture between the University of Bristol and the University of West of England. It's home to lots of other startups, and a few other drone startups have been through there as well. I'll give a shout out. It's an amazing place, and they've been really supportive. And it's the physical space where we can do the physical work. So we'll 3D print things there. We'll do the soldering there. We'll assemble the aircraft there. And then there's also an indoor flight arena. So we'll do a lot of the testing indoors, and a lot of the sort of pre-field testing in there, which is, you know, knowing the British weather, it's really useful to have a place where we can test the aircraft indoors, because we've obviously, if it's super rainy and super windy, that sometimes removes the option to fly outdoors. So yeah, on a day when we're all together, we'll come in and we'll talk about the version of the aircraft that we're currently building, talk about any elements we want to add or remove, and then we'll go away, and then somebody will be building it. There's different work packages. So there's the planocopter, which is the novel aircraft, and then there's we're building a few. They're called Talons, so which is a foam aircraft, a fixed wing aircraft that we also fly, and we'll fly that one around, and we'll basically we practice flying that one around in the same manner that we will fly the planecopter around when the transition has been automated. But also we practice using it in a commercial sense. So it's got a camera on it, and we basically we're using that aircraft. We're getting that aircraft to fly as if it's flying a commercial mission, and then we can then take the learning from that and then put it into the special aircraft. So yeah, so that's it. We get together. There's only a small group of us. It's quite informal. We talk about the drone. We build the drone. We test the drone. We fly the drone.
It's all about the drone.
Yeah.
And do you get together occasionally for a beer, or outside of work, or not so much? Or maybe you guys don't drink that much. I don't know. Quite right.
We do you know, we like to go there. There's loads of networking events in Bristol for founders and for entrepreneurs. So we usually go to those and eat free pizzas and drink the free beers. We're fond of doing that. And then on the weekends as well. So we usually go. Sometimes we fly during the week, but it's pretty often we'll go flying on a Sunday. And as you can imagine, it's sort of a work day, because we're doing some test flying, but it's also a Sunday, so the atmosphere is very relaxed, and we'll also bring our own drones and we'll fly them around and just do it in a really nice way.
Yeah, that sounds like really nice. So you guys have a lot of fun together doing that naturally. Yeah. Okay. Well, that's really interesting sort of chat there, Alasdair. I mean, I guess you've probably covered this already, but what are your main, just to sort of end off now, to finish off, what are your main priorities now when you get back from tomorrow and over the next few weeks, months, or 6 months? What's your main aim?
Yeah, I'll tell you about the next 6 months or the next year. So we are constantly improving the aircraft itself. So there's the technical development of that. It's getting bigger. It's getting more robust, more reliable, and we're adding in more gadgets and features as it gets bigger. And then also it's going to be extensively tested. So all the flight performance data is going to be evaluated, and then when we go to customers, we can then say it's a VTOL platform, but look at this extreme range and this extreme speed. And then there's also a number of demonstration flights planned later in the year for people who are interested in either buying it or operating it. And then there's also all the other things that come along with a startup. So getting the pitch deck ready and all the materials for that, and then going away and looking for some investment. We're looking to raise about £350,000. We'll be through SEIS, and that will be early next year. I think we'll be doing that. But obviously the work for that begins now. And there's also there's a number of other funding opportunities that we're chasing. For instance, there's some DASA competitions that we're going to be entering, and a whole range of other stuff. We're very busy.
Yeah, I'm sure, and I'm sure it's all about. It must be quite a challenge to sort of juggle, driving forward what you're doing with the thing itself, and also trying to sort of get yourself out there and be trying to get in more interest and potential investment is probably perhaps quite a tricky double act to do, isn't it?
Yeah, it is. Yeah, and it would. It takes. You have to do both, and you have to strike the right balance. But you also, we have a product we're developing, but we can't wait until the product is finished before we go away and start selling it. We have to lay the groundwork now and let some people know we're building it, and then get the interest ahead of time. You're right. You've got to do lots of things at once. It's a good challenge.
Yeah, no, it sounds fascinating and really exciting, and you're doing it. I think at the right sort of time of your life as well. You've got that young energy as well with your colleagues, and and you're quite fresh in terms of what you've been doing, yeah, I think hopefully you've got a lot of potential there.
Thanks. Yeah, I think I started when I did because, I mean, I think I knew it would take a long time to do. I think my vision for this company is a very long-term one, and we're thinking about next year, but we're also thinking about 5 years down the line, 10 years down the line, 20 years down the line. And as the founder as well, I think I recognize that it will take me quite a long time to become a good founder, if that makes sense. So I think some people who have done this before will tell you that you have to doing things like leading a team and doing things like giving pitches or doing all of these things. You get good at them by doing them, and the only way to get good at them is by actually doing it. So for me to want this company to be successful in 4 or 5 years' time, I have to start now. Or the earlier you start, the quicker you can build up experience and the quicker you can get good at it. And that's what it was all about for me. I thought the sooner I start this, the sooner I can learn the ropes. The sooner I learn the ropes, the sooner it will, for lack of a better word, take off.
Yeah. That's great. Well, thanks for that, Alasdair. It's been great chatting with you, Alasdair Aegerter. What's the
Aegerter.
You say your name?
Alasdair Aegerter.
Alasdair Aegerter. Okay, great. I want to make sure I've got your name right for the listeners. Alasdair Aegerter, CEO and founder of YEET Aerospace. Thanks ever so much for your time and for talking with us. And as I mentioned earlier, you are on our program for the Aero Engineering Forum at Advanced Engineering, which is happening on the 1st and 2nd of November this year at the NEC in Birmingham, its usual venue. So it will be great to have you with us, Alasdair, and telling us more about how the drone's been going on and some of the technologies that have been feeding into it. And one of the watchwords of this year's show will be sustainability as well. So I think some of what you'll be talking about perhaps will fit in very well. And as I say, the guys, the folks from Ultrafan Rolls-Royce, the chief engineer Pete Young will also be talking amongst other people as well. So we probably have a panel session actually about sustainability with 2 or 3 different people. So perhaps hopefully you can join us on that. But yeah, it's been really good to talk to you, and wish you all the best and very good luck with the rest of your work with the drone at YEET Aerospace. Thanks very much.
Thanks for having me, Jeremy. And let me just say, I'm really looking forward to the expo, and I'm really looking forward to giving a talk.
Great. Well, us too. So thanks ever so much for joining us. Okay, cheers. Thanks, Jeremy. Thanks, Alasdair.